Good evening. Wow, this is a bit overwhelming. I'm glad you all honor Earth Day so seriously and come to the Nature Institute for that. Thank you. Earth Day, as a celebration, began in 1970, which a number of you in this room, as I do, will remember. And I remember, it might not have been exactly that year, but when I would ride my bike on my way to high school through the campus of the University of Colorado, some students started putting up signs in the bigger grassy areas, small signs. They weren't in your face, but they were down there to see, and they said, "Give Earth a chance." And I don't know if that was a widespread phenomenon everywhere, but it made a big impression on a lot of us, this give Earth a chance, even though if we still like to walk across grass. So this honoring the Earth, giving our attention to the Earth, if you think most of our holidays are around people, events, some events, and here we have the Earth, the planet, that supports our lives. And so tonight, what I want to do is to speak about the Earth through, you could say, through the lens of the plants, the plant world. And I must say then at the very beginning, there's a lot that I will leave out about plants. So I apologize to the plants for that what I'm leaving out. And I'm leaving out a lot about all the creatures that they interact with. But you'll see. Before I get into the material itself, I want to mention one thing. It's a question that's becoming more and more kind of central to some of the work we're doing here. And it's the question, is it possible to concern yourself with another kind of being, plants very different from ourselves, but to do it in a way that you could call it planterly? That word doesn't exist, I don't think, but you understand what I mean, in a planterly way. And the reason that's come so into focus is because we have a project around the topic of plant intelligence, which is a big topic in certain circles in the biological sciences and is also in popular media. And one of the characteristic features of a lot of the research results and the way the research is interpreted is that one speaks about plants making decisions, choices, strategizing, remembering, even thinking. And that kind of language, I have the feeling, and I think it's more than a feeling, also brings us away from plants. It's a certain helplessness to interpret plants in the only way you can do it by making them more human, rather than to try to see, well, how are plants actually really different from us? And when we say they're really different, doesn't mean we don't like them or that they're weird or they're bad or they're really good, but to try to get into that difference as a human being, because I can't leave myself behind. So this is a challenge. But I wanted to give that as a preface, as a striving to say, can I get into the plant world in a more planterly way as a task? So that's kind of in the background of what I'll bring this evening. One very simple phenomenon that we all know, but we probably don't pay attention to, I know I don't often enough, and that is when we're out, like here in the Northeast, in the world, walking around, not on asphalt, but where there are plants, then everywhere we see plants, plants, plants. But it's a very different situation than seeing 20 deer on that field over there, right? I walk over the field and I say 20 deer. I don't see 4,265 grass plants. I see a meadow, or I see a forest, and here and there I see individual trees. But do I really see individual trees? Well, I go, okay, there's the tree, there it goes, there it is, and disappears into the earth. It's part of that, it's not separate from it. And this experience of plants that we don't have normally as individual, discrete creatures, which makes them very different from most animals and from human beings. That they all, and because we all know plants a little bit, we can say they rise up out of the earth. They grow out of the earth. They're connected with the earth everywhere. And now I know, so I don't have to say this a number of times, I'm not thinking of all plants. There are plants that move around with water. They don't move around, they get moved around through water. All the plankton in the ocean. I'm leaving those out when I'm speaking about the rooted plants. So these plants that are very strongly connected to the earth and all are like members, differentiated members of the earth. And in certain areas, that's a fairly closed, like a carpet in a meadow or in the forest where you can then see open areas, or along a stream where the stream bed is taking away the plants and you only see the soil. And then we have areas like in the western United States of the deserts, where the plant carpet is not a carpet anymore. It's a patchwork of little groups of plants. So that varies around the whole earth, and I'm not going to go into all the different varieties of the clothing of the mantle of the earth that plants are. This connectedness with the earth. And we can really become clear about that if we take the one expression of plants where plants are independent, and that's when they're seeds. A seed is a whole plant. A seed is a whole plant. But it's a plant without a context yet. And so it's not showing its planterly growth and transformation until it comes in contact with the earth and lots of particular conditions depending on the seed of moisture and warmth, etc. And then when that seed germinates, then it brings down, it grows out and brings down a root, and then a shoot, a stem in the opposite direction. And this germinating seeds, seedlings, are this wonderful expression of the relatedness to the earth, because what direction do the first roots take? Down, straight down. But what does straight down mean on a spherical earth? They're all pointing to the center of the earth. All the tap roots, all the lovely carrots are all pointing, it doesn't matter where they are, they're pointing towards the center of the earth. And the upright trunks of trees are also radii of the earth. So every plant in its initial coming into the earth and out of the earth shows this relationship that it has to the whole earth as one part. So you have this amazing connectedness with the planet in a way that animals don't have and we don't have. We have connections, but in different ways. I'd like to look at the beginning, roots and rootedness. And that is a bit of a problem, because roots don't like to show themselves on the whole. So we usually have to do something in order to make a root growth visible, or even to see that there are roots. Those of you who work in gardening and agriculture have a lot to do with roots, but most of us have very little experience with roots. But there are a lot of researchers over the past 150 years who have concerned themselves with roots in various ways. And I'm drawing on all of their research in what I'm going to bring. I was just pulling out a few plants from our garden over here that we call weeds, which is not a very nice name. Emerson said weeds are plants whose virtue has not yet been recognized. When I pull them out, and you listen when you're doing it, you hear all these roots tearing. You never get a whole plant out of the ground. You're always ripping it out of its context, and it can be a little bit painful, but it's good just to recognize that you're loosening it and tearing it out of the context that allowed it to be what it is. And It's very difficult to study roots without doing that. And there are very few people who have done it. And I just want to mention them and honor them this evening. And one is an American botanist and ecologist, John Weaver, who worked in the 1930s and 40s in prairie in the West, Kansas and Colorado and Nebraska, and did lots of research on prairie plants, but also on crop plants. And he and his graduate students dug out plants really carefully, and then made drawings of them, some photographs, but lots of drawings of the forms of the roots. And this was taken further by another group of researchers a bit later in Austria, and there you get a little bit of sense of some of the things they did. And this is a root atlas. I think there are 7 volumes of this work where they dug out plants. I'll just show you the slides. It comes from that. This is Laura Kuchera and her colleagues. But this is a work that will never be repeated. This very careful, what shows itself down under the earth of the rooting bodies. So I want to show a few slides now. This was the picture that was on the poster that we put out, that the people from Austria did. Weaver did similar things, that he took a group of plants that grow together. This is a meadow in Austria, and plants that grow next to, and of course not only next to, but this is in the 2 dimensions, each other, and their rooting bodies. And this goes down to a little over 5 feet, is to here. This is 5 feet. So you can see, on the one hand, in this case, how deeply the roots grow, but then each plant in its own way. This grass plant, incredibly dense roots, very bushy. Here, one with a taproot and branching more lower down. This, a very interesting one going, and then down here at the bottom, branching. Here also, a lot of branching there, less here, more here. You can imagine when you're digging these out, you can hardly separate the different plants from each other. The roots just go in each other. They don't fuse, as far as one knows normally. They're completely interconnected, intertwined. So this very intense taking hold in the earth, that's one way to look at it, taking hold, rooting through growing in lengthwise, kind of a radial growth, down, but in all directions afterwards, and branching. That's kind of the principle of roots. And you don't get, in the sense of that form principle, nearly as much differentiation as you get above the ground, right, from the form side. Then if you look at one individual plant, this is then the upper part was cut off. This is from a nightshade, a black nightshade. And this goes down to about 2.5 feet and spreads out to the side, but they also looked at it from above. Right, so now you get more the 3-dimensional, which we always think in these 2-dimensional pictures, you think it just goes down like this, but it goes right in all these different directions, radiating out. And the radiating out, how does that occur? The roots grow at their tips. The portion of a root that's growing at the tip is very small, just a couple of centimeters. So the tip grows, and it leaves behind it the root. So this is the way plants move through the soil, very slowly through growing, and they're always moving into new, through moving, growing, into new parts of the soil. And they're growing as long as they live. They can have a dormant period, of course, in the winter if it's a perennial, but then it will start up again. And the root growth of tips, and then soon behind the tips, if it's a branching root, it will begin to form the branches. And then the branches do the same thing, growing at the tips. And the most active life is always at the tips. So you have to think of this incredible life activity at each one of these tips. And it goes a little bit further. This is a small grass plant. This bar here is a centimeter, which is this much. Right? I grew in a pot, and then I pulled it out very carefully, loosened it from the soil was very loose because I knew I wanted to do this. I pulled it out, and when you pull a plant out, it's always got all the earth stuck to it. What does that mean? The roots don't let go easily. The soil is really, in a way, embedded in the rooting body. And then, looking at a detail, that's the same scale, so it's a centimeter. It's this little portion here. And there you have many fine little roots, but you can hardly see them because everything is covered with the soil. And then you shake a little bit more carefully, like this. Try to get it a little bit off without damaging too much. And then I looked at the roots under a microscope. And so this is the tip of two side roots. And you can see how the soil is still clinging. The roots secrete a mucus, and the earth clings to it, or they cling to the earth, however you want to put it. And then you have these wonderful structures that are called root hairs. They're absolutely tiny, very fine, as a little band behind the tip. And these root hairs, in a way, each is a mini root itself. Each root hair is an extension of one cell. And those are the places where the active relationship to the soil in terms of taking up water, also secreting substances into the soil, all that happens through these root hairs. So you can imagine the surface area down there of the plant, going into every nook and cranny, so to speak, of the soil. Here, I like this one. They wouldn't let go. These are tiny clods. This is maybe a millimeter in diameter, if that. The very, very strong connectedness to this solid world, but it's not completely solid, the soil, of course. It's solid, has little rocks in it. And on the other hand, there are air spaces, and I'm not going to go into a lot about soil now. The roots are continually creating new spaces within the soil, loosening the soil. They're secreting substances into the soil, breaking down minerals. They're taking substances up, water and minerals. And everything it takes up is fluid. It doesn't ever take up anything that's solid. Everything has to be dissolved. Any minerals that we say a plant takes up through the roots comes in the form of fluid. It's in the moist, dark, pretty solid, a world rich in contact. Everything's contact. And then all these fine interactions happen that people are still researching all the time. All the micro activities of what's called the rhizosphere, the little area right around the roots. All these things that are going on. Lots of activity. I want to show you a couple more pictures, and these are things you hear about a lot these days, which is about 80% of all plants have connections with mycorrhizal fungi. That means that the fungi grow into, around the roots, and extend the rooting body. And that can be only to the fungi themselves, or can also connect plant with plant via the fungi. So it gets even harder to say where does a plant end in the soil, because there's these connections. And I just wanted to show you a couple pictures out of some literature. Here, the dark part, those are the roots, and they're very fine. That's the fungal network, the mycorrhizal network that you hear about a lot. And so that's extending plantness through fungi even further into the soil. The roots are giving off substance to the fungi, and the fungi are bringing water and minerals into the plant as well. And then here, these are the fine, the hyphae, the individual threads, you could say, of the fungi are shown here. That's the root, and that's the root. What's interesting And this is, I just had to really make this a bit bigger than it wanted to be from from that article, so it's a bit fuzzy. But this shows here, and here where those two arrows are. Those are where the fungi from one plant, the fungi from the other plant connect, so that they're creating the connection between a leek and some type of cherry tree. This is where you get the underground connectedness of plants with each other, and shows even more. This is earth. The plants are earth. Now, the below ground plant. The below ground plant, of course, cannot live without the above ground plant, and vice versa. So I'm going to leave out a lot about the above ground plant, which I've spoken a lot about and written a lot about. That was my focus for a long, long time. But I want to just call attention to the following, that just to make clear that we all kind of feel how different it is for being in a realm of immediate contact with fluidity, substance, ongoing transformation in very fine ways, but dark, somewhat warm, fluid, but dense. And then you come into the realm of air and light. And it's in the realm of air and light that we can have distance, that we can move through easily, and that the plant forms itself very differently. On the one hand, though, it does have the branching, the radial with the stems, and the leaf stalks, for example, the side branches. So if you think of the trees that we can see so well now in their branching before they get all their leaves, you also have that radial tendency which never mirrors what's down below, but is something similar in this branching. And then the other element of surface, leaves. Right? So spreading up, branching up out into the air and light, spreading into the light and warmth and cold, depending, and living in that context. Very different from what it meets down below. But the two need each other. I'll come back to some of this later. Can't do everything at once. You have the polarity of the below ground, the above ground plant, and they are continually communicating with each other. I don't like that word, but I said it, didn't I? Just think of the water that the roots take up, streams through the roots, goes through the stems, out into the leaves, and is very important for physiology there, but then also evaporates or transpires, as biologists say. So you've got a continual stream of water going out of the earth, up through the plants, out into the air. Right? So you have that ongoing, and the plants are always mediating a relationship between these two parts of our world, the below ground, the above. Right? They're mediating that. And they are the ones that are happy not to move around. I'm sorry, now he's being anthropomorphic, right? Whether they're happy, they do it, right? And they do that they are these creatures of a place, and they bring themselves to expression in a particular place and are always relating to the elements of that place, of light, air, warmth, water, minerals, solidity. This is, in the mustard family, a rapeseed. It's a relative of canola. So yellow mustard flowers, beautiful. Growing in one particular context, in another context, and in another one. These were done by the Austrian people. These are all from an area in Austria. These were growing closer to each other, but the soil was different. It was mainly the soil that was different in those two cases, in the middle and on the left. And in the one, the lower part of the soil became very sandy and gravelly. And the plant didn't go into it further. It stayed mainly in the upper regions, and when it got down into here, it stopped branching. Whereas here, the soil was rich to a much greater depth. It goes down to about 1.25 yards. It's always important to realize how far they go down, because we often think of the roots just up near the top. And this plant, which grew also in a very good soil, was in an area that was wetter. And its rooting body developed completely differently. And you can see the above ground plant, especially in these two you can compare better because these were drawn at the same time, that you have a very different kind of branching pattern, the smaller leaves, here the branching at the top, more flowers and fruits and seeds, and here it's more compact, broader leaves. The one on the left was drawn at a little bit later time, so a lot of the leaves have died, but they were smaller anyway. They've died off, so it's not really comparable, the above ground plant. But if you just think that of 3 instances, and just imagine you did this with 50 different ones, what a picture you would get of the ability of the plant to be and develop in a particular place and always be responding to those conditions that are there in its way, but uniquely, right? It's never like anywhere else. It's always a bit different. And that possibility is given to every plant. And that's again showing you place. I'm committed to the place, so to speak. And I can bring to expression characteristics of the environment in the way I grow. And I want to show you one extreme example. This is an alpine plant, an alpine poppy. And this grows down to exceedingly deep. This grew down to about 2 yards, and it's a gravelly soil. It's a gravelly soil, and it grew pretty much straight down. Same species. Also in the gravel, in scree, if you have a concept of scree, it's kind of the gravelly rock that moves slowly down the hillside in mountains. And this was on that slope. And its roots are not only growing down, they don't go down nearly as far. These are to scale, it's the same scale. They're growing along the surface, and they describe then the ones that are growing up were often at the very end growing like this, like little hooks. Little hooks. They were anchoring themselves in this slowly sliding slope. And that they respond to those conditions, they find their home and make their home, create a home in completely different ways depending on where they are. That's an amazing capacity of plants. Absolutely phenomenal capacity. This capacity of the plant has led me to think in the following way, kind of a thought exercise. When we say a plant grows out of a seed, which is a very rational, reasonable thing to say. Plant the seed in the earth, and out of the seed the plant grows. But if you don't take the world into account, then it never does that. The seed by itself never does that. So if you think of it this way, think of it in the opposite, from the opposite direction, so to speak, say the environment, this is hard, the environment becomes the plant through the seed. The environment becomes the plant through the seed. Because each plant shows you something about where it's growing. Any plant you can look at, you can see something of its relatedness to its environment. And so it's not only showing you, I am a beech tree, I am a beech tree in this context. I am a beech tree in that context. I'm a rapeseed in this context or that context. Alpine poppy in this or that. So it's always showing you itself, and it's showing you the world out of which it's grown. That means that world has become part of it. And without it, it could not be. I call this the seed perspective. It grows out of the plant grows out of the seed is the centered one. And then you have the peripheral perspective, where you have to say, they only through its connectedness through a larger context, and that larger context working into it, can the plant be plant. And without thinking those two together, we don't have the plant. We have a surrogate. And even that's not the whole plant, I'm sure, but it's an approach to getting it more real, to getting a more real sense of what the plant is. You can imagine at some time in history, you have these inquisitive people who ask, well, how do the plants grow? They're not running around eating each other like animals do, or animals eating grass. How are they doing this? And this actually started in the, about this early 1600s, and then took off in the 19th century, 18th and 19th century. I just want to give you one example. A Dutchman, von Helmont was his name. He did an experiment. He took 200 pounds of dried soil and put it in a pot. And then he took a shoot from a willow tree that weighed 5 pounds. The soil he had dried out, it was dry, had no water in it. He put the 5-pound shoot of the willow in it and started watering, either with rainwater or distilled water. And he did this for 5 years. And then he took the soil away from the plant, out of the pot. He separated the soil from the plant. He weighed the plant, and the plant was now 169 pounds. So it had gained a lot of weight in that period of 5 years, 169 pounds. He dried the soil, and it weighed about the same as it weighed before. So he thought, what's making the plant grow? Where's the plant getting everything from? From the water. His thought was from the water, but not from the soil, which was interesting, because a lot of people would think, well, it's all come from the soil. So he thought, But then other people kept doing experiments in this way, and they came to see, on the one hand, water is really important, as we all know. When you let your plants dry out, what happens to them? So a lot of the form and stability of the plants, even wood, fresh wood is 50% water. If you dry it out, it loses half of its weight. But most living parts of plants, where it's growing, in the leaves, and of course it depends on the individual plant, but let's just say 80-90% is water. So you dry out a plant. If a plant dries out, it loses most of its substance. That's water that disappears out of it. Water is not only a physiological but structural element in plants, quite different from us, again. And so you dry out the plant. It's called dry weight or dry matter of the plant, 20%. That's not water, but where is it coming from? And this is where scientists, through lots of really interesting imaginative experiments and then a lot of creativity and figuring out how to do the experiments and show things, where does most of the substance come from of the plant? From air. From air. And not from all aspects of air, but from carbon dioxide. So that most of the substance of the plant, and that's 90%, right? 90% of the substance comes from the air, 6% comes from the water, and 4% comes from the minerals. Now those are numbers. And numbers are interesting because they can just be boring numbers, but they can also be something you say, wow. I remember actually my son coming home from college when he'd relearned this and being amazed. He said, plants are air. Of course, not the air like this. There's an incredible process of densification happening to create living substance, I should put it this way, to create a fluidity of living substance that can become more dense and solid, even into wood formation. So if you just think of a creature on Earth that is able to make a living body out of air and water and a little bit of the mineral world, then you have what I called the talk, the wisdom of plants. There's nothing that compares with this on Earth. What plants do in making their living bodies out of air and water and a little bit of the solid world that has to come into it as fluid before they make that. On the one hand, I feel like it's great just to think plants are congealed air. But now I'd like you to just follow me a bit. Imagine when I'm speaking these words something about taste or smell. Lavender, onion, thyme, chamomile, chili pepper, sage, cilantro, rosemary, ginger, garlic, basil. Now, not so much the smell, taste, crocus. Think flowers now. Crocus, snowdrops, forsythia, daffodils, and the shad bush that are so lovely flowering right now. Right, these early spring flowering creatures. And those of you who go out in the woods like I do now, imagine my favorite, skunk cabbage. Never give a talk on plants without skunk cabbage. Skunk cabbage, bloodroot, trout lily, Dutchman's breeches, blue cohosh, trillium. Do you see how saying congealed air is not quite enough? When you study plants, and then in their individual expressions, not only form, but into this incredible world of substances, the diversity of substances that any given plant produces is mind-boggling. And then you have all the specificities that this plant creates a particular substance that's nowhere else. And this one creates another one that's nowhere else. And the scents and the forms and the colors. There is an amazing creativity in the plant world, making out of something very diffuse, air, water, and minerals, creating diversity of living substance and form all around the earth and everywhere different. The interesting thing here I've always found, and I'll give you an example from when I was teaching at Hawthorne Valley many years ago. And I had a course with the seniors in the spring where we went out back up into the woods there and we looked at plants, we drew plants, we keyed out plants and described them. And that was the main part of the course because seniors are hard to get to do anything at the end of a school year before they leave. They usually got into this, and we were at the top of that hill there, a little bit later than now in the spring, and we were looking at and drawing the columbines, these beautiful creatures, the red columbines, the eastern columbines. And one student, young woman, we were all sitting there quietly drawing, and then she said, "Mr. Holdrege, where do all these plants come from?" Very good question that does not want an answer from a smart teacher, right? You understand. That question shows she saw something as a question where she saw there's this unreal quality to the intricacy in the colors and forms of this flower. Where do those come from? And that element of the configuration of form and colors and substances, we can only basically say, this is earth creative. This is earth creative. And because I've been fortunate to travel quite a bit around different parts of the earth, in all these different places, these individual expressions in the fynbos of South Africa, an amazing plant life that's like nowhere else on earth. So everywhere the earth is individualizing itself, not in the sense of running around as individual bodies, but as bringing forth creatively expressions of itself in different places, in different times. That element of the plant being this mediator between heaven and earth, you could say, but creating its own unique world that allows everything else on the planet to live. And this is what we all know, but it's always too bad when one only knows things and doesn't actually feel it deeply what that means, to say that the plants are creating all this living substances and all this diversity, and that creates the food for the bacteria, for the fungi, for all the animals, and for us. And they create it in such an abundance that they can continue to do it. When a plant gets eaten down from the top, then it can regenerate and come back up. There is an incredible abundance of living forces that the plants bring to our planet. And that abundance in the food and the abundance in, for example, creating oxygen that we breathe. The oxygen of our atmosphere comes from these creatures, and we don't even know it. I mean, again, we know it. We don't sense it, is what I meant here. We don't sense it. It's a gift of the plants to the world. And in that oxygen is a result of a transformative process, and that brings us back to where the plants live from, in this taking in the carbon dioxide. And carbon dioxide, it's become a little bit of a bad guy through our climate change problems, but we have to think of carbon dioxide as being a central origin of plants. And so this gas that we can't smell and that we can't see gets taken up in a very, you could say, invisible way into the plant. Incredible transformations that I will not go into through light and warmth and water. It then can create its substance, and then in doing so, give off the oxygen that the animals and the humans and fires, bacteria and fungi all need. And what's interesting is those two stay in a pretty dynamic balance until there are certain big catastrophes, if you want to put it as a catastrophe, a huge volcanic eruption, right, that can change things, or when human beings start using all the fossil fuels. Fossil fuels, plant life of the past. Organic life of the past, a lot of it plant life. So we're drawing on the past and putting a lot of that into the atmosphere. And what do the plants do? So you're all aware of the rising carbon dioxide levels, and the carbon dioxide is a minuscule amount of the atmosphere, 0.04%. Tiny amount that's absolutely essential for life and for the mildness of our climate as one of the so-called greenhouse gases. And so you have the carbon dioxide being increased, and what do the plants do? They take up more. So that the climate scientists think if we didn't have the plants we have, even with deforestation, we'd have a third more carbon dioxide in the air. Because the plants are taking up more. They've been taking up, this is like even in the last 20 years, these are numbers from the last 20 years, that they're growing more. There'll be a boundary to that they're taking that in. and making living substance out of it. Here you get the impression of the side of plants that you could say is receptive. Receptive to the light, receptive to the air, receptive to the water and minerals. And then actively transforming and contributing to the health of the planet. When we think about the Earth Day from the point of view of the plants, then we come to begin to see the Earth as something very alive. As very alive, this living mantle of the Earth that's in continual transformation, that brings forth a wealth of form and substance that supports all other life on Earth. And it's clearly the case that we human beings should pay more attention to plants. Not that we all become botanists or anything like that, or that we study plants, but just to realize we walk on the ground. Here we're walking on plants. When we're walking on the ground, we're rarely walking on just the mineral earth. We're also walking on these plants. I'm saying tread lightly, in the sense of becoming more and more aware of these creatures that let us do an awful lot with them without aggressively responding, at least apparently. That one takes their qualities in with this sense, you could say, of thankfulness to these creatures that make our lives possible, and to see how we, together with them, can evolve in a healthy way. I think that's a message of Earth Day. Thank you.